All right, this is Campbell's Biology, 7th edition, chapter 24, The Origin of Species. So we're largely talking about Darwin and some various things, the mystery of mysteries. A lot of what Darwin learned was from the Galapagos Islands, where he found original species of plants and animals that he didn't see anywhere else, and interesting variations. So origin of new species, or the term speciation, is the appearance of new species. Due to biological diversity here, differences are good. So evolutionary theory has to explain how these new species originate, and more specifically, how populations evolve. Those two things are tied, of course. So macroevolution is the evolutionary change above the species level. That's a complicated way of saying it's the formation of a new species. In chapter 23, we talked about microevolution. So there's two patterns of change here, one less common. Anagenesis is kind of what people describe when people say humans evolved from monkeys, as people like to joke and say, well, that's not actually accurate because monkeys still exist. They didn't evolve from monkeys. They share a common ancestor, which is the cladogenesis model, where this common ancestor potentially no longer is around. These two derivations of that are, and they're different species. So how are they different species? The biological species concept says that they have the potential to interbreed and produce fertile offspring, but are unable to. The potential meaning they live in the same area where they can interbreed, but they can't interbreed and or produce viable fertile offspring. So the very common example is when a donkey and a horse mate, they produce a mule. Well, a donkey and a horse are two different species. They can mate, but their offspring is infertile. Mules are all the same sex, and they're infertile. So within a species, you can have diversity, such as this, variations within that same species, and you can also have two different species that look really, really similar, such as this eastern and western meadowlark, where they're different enough that they don't interbreed. So quite often the reason they don't interbreed is because they're reproductively isolated, which are factors that impede members from producing viable fertile offspring. And there's a variety of different factors you can describe. Sometimes it's a combination of different barriers. And we lump these barriers into prezygotic and postzygotic barriers. Postzygotic barriers prevent the two adults from mating to begin with, basically, from forming a hybrid zygote. And, Postzygotic barriers prevent the zygote from developing into an adult. That's after the zygote has formed. And prezygotic barriers are preventing the members from mating to begin with before the zygote forms. So there's different types of isolations that prevent mating, that makes things isolated from one another. For example, habitat isolation. These two snakes live in entirely different environments, so they simply can't mate. They never meet. Temporal isolation, you may have an animal who is nocturnal versus an animal, slightly different species that is diurnal, and thus they don't meet. Or maybe one is hibernating when one is active. Behavioral isolation, this one I like to describe as the teenage model, where if we continue this way, teenage boys and teenage girls will become different species. They are behaviorally isolated, where teenage boys act like idiots. So here's the teenage boy, and so the teenage girls don't want to mate with them. That sounds awkward. We're talking about teenagers. I don't mean it like that. But they're behaviorally isolated. They behave or act differently, so much so that they don't mate. It might be songs. It might be the mating dance, or what have you. Mechanical isolation. This is a complicated way of saying the pieces don't fit. So the way I typically would describe this in class is I would say if the only two species of dogs that existed on the planet were a Chihuahua and a Great Dane, they would evolve into different species because they are mechanically isolated. The pieces don't fit. You can also have gametic isolation, different ways of producing gametes, or the gametes don't physically combine. The sperm can't fertilize the egg of the other species. And then if they are able to mate, these postzygotic barriers are all variations of basically reduced viability of the hybrids. Essentially, they're infertile and can't produce offspring. Here's the horse, donkey, mule example there. So biological species concept is the most commonly accepted one, although we can't use it to describe asexual organisms, of course, because they're not having sex with one another. We can't do it with fossils because we don't know enough about the fossils and how they mated or what choices they made. Or organisms that we don't know enough about their reproductive habits. There's other species concept. There's the morphological species concept, where they're different just based on how they look. Paleontological, this is based on the fossil record. We do use this fairly frequently with fossils. They're known based on their morphological differences in the fossil record, so we say they are paleontologically different. And quite often they'll be reevaluated and they may merge into one, such as when you were kids, the Brontosaurus existed, and today the Brontosaurus doesn't exist. It's been lumped in with another dinosaur that was said to be the same, and I want to say it's the Brachiosaurus. The ecological species concept, basically they live in different ecological niches, so they are different. And the phylogenetic species concept, basically a different genetic history, so they can't reproduce. Different phylogeny. And we'll take a pause on this one.